For this example, we will be factoring this following expression using substitution. And the reason we need substitution, as I look at this expression, I see some symbols in here that complicate the situation. It's not just a polynomial in x, which is the sort of thing we're used to factoring, but we have these e to the x terms that are popping into place. And actually, it's not only e to the x, it's e to the 2x. And so what I'm realizing is e to the x is what's kind of in my way. It's what I like to think about as the ugly thing that I need to get rid of. And so u for ugly, let's call this u is going to be equal to e to the x. So now I do see both an e to the x and an e to the 2x, but those two things are actually related to each other. Because if you square u, we would get the e to the x quantity squared. But using our exponent rules, we have a power to a power. So when we have a power to a power, we multiply the exponents. So x times 2, we would have as 2x being our exponent. So e to the 2x, that little 2 that's sitting there is really just the power on e to the x, if you want to think about it in terms of kind of a polynomial-like thing. So when we do that substitution, what we have now is 4 u squared, because the e to the 2x is really just u squared in our substitution, plus 20 times u plus 21. So now this is a polynomial in terms of the variable u. We didn't really want to put this in terms of x because x is already being used as an exponent on e here. So I like to use u for thinking about this as the ugly part, that if we could make a substitution, the expression itself would be less ugly in some ways. And now that's what we have. This is just a simple polynomial in u. Now I say simple, but it's only as simple as it can be as if we factor this and we have a leading coefficient that's not 1, and those are more challenging to factor. So we're going to be doing the factoring by grouping through this, so we need a pair of numbers that kind of does our trick here. So we have a times c, which is a is 4, it's our leading coefficient, and c is 21, which is our constant term. So a times c is 84. Okay, so 84 is the product that we need to split up into two different terms that are multiplied together, that when you add those two factors, you get b, which is our 20. It's the coefficient on u. And so I'm looking here at factors of 84. And I think ahead, because we are looking at a product that is positive and we need a sum that is also positive, both of these factors are going to be positive. So I don't have to think about what would be negative at all. Nothing's negative. Everything has to be positive. So we're going to look here at 84. I mean, we can start at 1 times 84 and realize very quickly that that sum of those two numbers, 1 and 84, is not going to give us 20. So we can move on past that and see if the next one works. Now, perhaps you don't need to write out all of these. Perhaps you can jump straight to something that would work. But writing them out, make sure you don't miss it. If you're struggling to find what these two numbers are, a systematic approach could work. So 1 went into 84, 2 goes into 84, and that would be 42 times. 3 goes into 84 actually. 3 times 28 gives us 84. 4 goes into 84. 4 times 21 would be 84. And you see we're getting closer. The sum of 4 and 21 is 25, and so we're getting much closer to that 20 target that we have. Continuing on to the next factor, 5 does not go into 84, so we can move on to 6. 6 times 14 is 84, and that's the one that's going to do the trick. Because 6 plus 14, if we take those two factors and instead we add them together, that gives us 20, which is our b value. Okay? And that's what we were looking for. So the pair of numbers that we have here to work with would be 6 and 14. So that pair of numbers is going to be used to split this middle term here. This 20u is now going to become two terms. So we keep the 4u squared at the beginning, but we break 20u up into two terms based on the pair of numbers we found. So 6u plus 14u, because 6 and 14 were our numbers that we found. And then we have the 21 at the end. And so now what we've done is we've taken a 3-term polynomial and we forced it into a 4-term polynomial, and we're going to tackle this factorization by grouping. So we group them in pairs. So looking at the first 2 terms, we look for the greatest common factor. So looking at the coefficients, we have 4 and 6, and the greatest common factor we can pull out there is 2. And the biggest thing we can pull out of u squared and u would just be 1 copy of the u. So when we pull out 2u, that leaves us with, not 4 there. When I pull out the 2u, it leaves me with 2, because 2 times 2 is 4, u, plus, and then it would be a 3. Okay, so that's what I get when I look at the first 2 terms. Now the next 2 terms, I know that I'm shooting for needing exactly the 2u plus 3 as my leftover part when I pull out the greatest common factor. And I do get that when I pull out the greatest common factor of positive 7. So we got to make sure we do get that plus sign there, because that's what's separating now 2 kind of complicated looking terms, but still 2 terms nonetheless. Okay. So now we see that what comes before the plus sign and what comes after the plus sign has the common factor of 2u plus 3. So I pull out that common factor to the front. And when I pull out that common factor of the 2 terms that are separated by the plus sign, that leaves me with 2u plus 7. And that would be our second factor then in our factorization. So now, we've worked really hard. We had to work pretty hard to find the numbers. We did the factorization kind of the long way with factoring by grouping. We should be done, right? Well, be careful. Look at the beginning problem. That problem had the variable x, but right now my answer as it stands doesn't have x in it. So I have one more final step to go to get to my final answer. I need to substitute back. See, I made the substitution u equals e to the x so that my factorization could be more straightforward, but in the end I still need my answer to have e to the x in it there. So I've got 2 times e to the x plus 3, because I replaced my u with e to the x, and then the other factor is 2 times e to the x plus 7. And now I am done, because my final factorization is in terms of x there, and we have completed the problem.